movements that create massive currents of energy. This energy is what produces the magnetic fields. And so, by observing how a magnetic field rotates around a planet, you could tell its day cycle. One rotation equals 1 day. However, Saturn doesn't play by this rule. In fact, Saturn's magnetic field is positioned on such an axis that it should be impossible for it to exist as long as it has. Its magnetic strength and orientation are about 580 times more powerful than Earth's, and yet scientists don't know just how this field is produced. Learning about how long it takes for Saturn to complete a one-day cycle took further extensive study beyond its magnetic fields. Scientists studied its radio waves and discovered that it emitted radio waves that rose and fell in intensity. And just as you'd guess, the rising and falling of these waves followed a unique timing. They noticed that higher levels of radiation appeared every 11 hours. This number tallied with the estimate scientists had deduced from Voyager 2's data. The Voyager probe had estimated Saturn's day cycle to be 10 hours and 40 minutes. And so, scientists decided to make it official, setting 11 hours as the length of time it takes for Jupiter to complete 1 day. But Cassini noticed that Saturn's speed of rotation wasn't constant. Over the course of its 13-year study, Cassini detected that the time it took Saturn to complete 1 day increased and decreased randomly. This was completely weird, and a major part of the scientific community didn't want to agree that the planet was exhibiting this weird behavior on its own. This group of experts opted to dig in further to find the underlying cause of these fluctuations. Scientists came up with the theory that something in Saturn's atmosphere was responsible for this. But were they right? Well, there's not enough data to tell whether these experts are right or wrong on this, but still, the deviations are quite minor, in order of plus or minus 1%. This means that the 11-hour day assumption is mostly unchanged. In any case, a huge planet such as Saturn shouldn't be giving irrational readings. There's just too much going on with this planet that astronomers can't wrap their heads around. The Cassini probe revealed that the heat from this planet isn't ideal, plus its auroras are off too. Saturn has a lot of auroras, but unlike Earth's auroras, which are caused by solar flares, Saturn's auroras are present with or without solar winds. Saturn's auroras are formed as a result of some electrically charged particles that emanate from Saturn's rings and moons. This is quite unique, and scientists are even suggesting that these charged particles have a contributory role to play in the planet's immense temperature. Saturn's rings are the largest in the solar system. These 7 rings were named according to their order of discovery. There's the B ring, the C ring, and then the D, E, F, and G rings. Just like the planet, Saturn's rings are very flat. The highest thickness Saturn's rings can boast of is 0.